Okay. Hi. Thank you.
Okay, perfect. So we should have the recording going at this point. Once again, greetings, everybody. Thank you very much for taking the time to join us today. Once again, my name is Hunter Wiley. I'm the host for today's discussions. Thankfully, I am not alone. We actually have a couple of our lead engineers and application engineers as well on the line. So just to give you a quick background about myself, my name is Hunter Wiley. I am the Panametrics Field Services. A little about myself. My name is Hunter Wiley, and I'm the Panametrics Global Services. I'm the Global Services Training Leader. Prior to my current role, I used to serve as a field service engineer across North America for several years. Serviced products across all of the Panametrics portfolio, both flow as well as gas and moisture. With that being said, I received my Bachelor's of Science in Petroleum Engineering from the University of Houston, and I'm truly very honored to be speaking with each of you today. As the Global Services Training Leader, I have modified this content in conjunction with our engineers as well, from what our instructor-led training courses can offer. Those will provide a much stronger understanding of each individual equipment pieces, directed towards technicians, engineers, and students. And as I mentioned, they are fully customized based on the relevant equipment at your facility. Our experienced trainers combine their proven teaching skills with hands-on application for a highly acclaimed learning experience. If you'd like any additional information, please feel free to visit panametrics.com/training. With that, I would like to go ahead and pass the torch along to Lachlan McNamara, who should be able to introduce himself. Lachlan, are you there?
Hey, Hunter. Yeah, can you hear me?
Yes, perfect. Thank you very much.
Great. Okay, hi, everybody. My name is Lachlan McNamara. I'm an application engineer on the gas and moisture product line. I joined Panametrics in 1996, started as a manufacturing technician and kind of worked my way through the business as service engineer for a good number of years, and I've been an application engineer for the last 3 or 4 years, designing custom sample systems for gas and moisture product lines. So yeah, I pretty much spent all my career working in the gas and moisture world. So looking forward to talking to you guys today, showing you some of our products and answering any questions that you have on those products. So thanks, Hunter.
Awesome. Thank you very much, Lachlan. An additional voice that we have on the phone, we have Mr. Mark O'Brien as well. Mark, are you able to share a little bit about yourself?
Hi, Hunter. Hi, everyone. My name is Mark O'Brien. Yeah, I currently work in the services group here in Ireland. I've joined Panametrics in 2000, my background being industrial instrumentation and applied physics. So my initial brief was that of a project engineer, so working with bespoke customers and EPCs around the world, who had specific requirements on project orders, so technical requirements and commercial requirements, and working with them. About 3 years ago, I moved into the services division. So I'm a lead services engineer now here in Shannon. And today we'll be talking about the gas flow or the gas analyzers that we currently have on offer. So looking forward to talk about that.
Perfect. And Mark and Lachlan both, thank you very much for joining and taking the time to share with all of us today.
No problem.
Yeah, looking forward to it.
Of course. Before we go any further, I would like to take just a minute to offer a brief safety moment. During these ever-changing times, it's important to focus on your physical and your mental health. Like many of us, you may be stuck behind a computer screen at your home, while others may be continuing to operate at facilities. Wherever you may be, please be sure to stay active. Take breaks to move around, perform stretches at your desk, and even take a walk if you're able. Find a way to connect with others. That may be through telephone or video calls to your family, friends, and even coworkers. Be sure to eat well. This is one that I'm personally working on. Meal prep may be a hassle at first, but it will pay dividends throughout the week. And finally, get some sleep. Find a way to limit your screen time, and especially for those of us working from home, ensure you hold to a set time so you can leave work. A quick history of Panametrics before we get going. Founded in 1960, Panametrics started off as a moisture measurement company. Though ultrasonic transducers were developed in the late 60s for non-destructive testing, Panametrics repurposed the technology for transit time flow measurement in liquid applications. Since that first commercial flow meter in 1979, Panametrics has continued to revolutionize ultrasonic flow measurement in various process conditions, while simultaneously growing its initial aluminum oxide probe hygrometer into a full portfolio of gas and moisture analyzers. Many industries recognize our legacy of excellence and our ability to provide solutions to even the toughest applications. We are Panametrics, a Baker Hughes business. And with that, I do want to go ahead and pass the baton over to, I believe, Mr. Mark O'Brien will be speaking today with us about the gas and gas equipment.
Great.
Mark, it's all you.
Yeah. Thanks, Hunter. So initially, guys, I just want to talk about the paramagnetic transmitters that we have. This is the XMO2, we call it, and it works on the principle that oxygen has a magnetic property. So it responds to changes in magnetic fields, and our instrument creates a strong magnetic field inside it, and we can direct the oxygen in various pathways using that magnetic field. So the more oxygen that's there, the more gas flow you'll get, or magnetic wind, as we call it. Now, as this wind transits across certain thermistors, the electrical properties of those thermistors will change. They cool or don't cool depending on how much oxygen is there. So then we can convert the change in resistance of those thermistors correlate the change of resistance to the presence of oxygen. So we have a electrical output from a transmitter based on the oxygen presence. So the XMO2 works on this. It has a very robust EXD package or weatherproof package where required. It's quite compact and can be, located in almost any environment, hazardous area or not. So if we just move on there, yeah. So you can see that's what the XMO2 looks like. It is roughly about 1 foot high and about 1/2 foot wide. It quite often is sold with either a weatherproof or an explosion-proof display. So that you can see the TMO2 there, in the middle, that's the weatherproof, and then the XTP above it, X-proof. They also have some nice software options available there on the display where you can have, say, hydrogen-cooled application software in there. The XMO2, not hydrogen-cooled application, auto-calibration function on the XMO2. So you don't even have to be near the XMO2 to do a calibration. It can be done automatically. Of course, the XMO2 as well can be supplied with customized sample systems or standard sample systems, depending on the application, or the customer can do their own. So if we move on a little bit, you can see here, just moving to the other similar looking transmitter, but a completely different technology, and that is the thermal conductivity analyzer transmitter that we have, and this is the XMTC. So it uses the chemical property of gas called thermal conductivity. So different gases will conduct heat at different rates. So hydrogen has a very specific thermal conductivity value, and it's shown on the scale below there, and it's quite different from other gases, let's say CO2 or air. So what we can use is the cooling effect that hydrogen will have with a given gas flow compared to a reference, so that could be air or something else. We can use that difference in cooling to create an electrical output. This electrical output can then represent the presence of hydrogen and corresponding concentration of hydrogen in that gas. Again, the package that this instrument can come in can be a weatherproof or X-proof, depending on your requirement. Again, it has the similar displays that the XMO2 has. Again, we can provide this with or without sample systems, and it has the required hazardous area certifications that are usually needed in this types of industry. So for hydrogen, a very common one is your hydrogen generators. You want to measure how much hydrogen is in there or not there, as the case may be. It can also be used in other applications like CO2 monitoring in fertilizer industries and so on. So again, it's a very robust package, quite small, and can be deployed in most areas. So if you want to move on one more. The third one that we have is the OxyIQ. This is a very compact transmitter. It is probably the size of your fist. If you just to elaborate, it has a little cell in there that basically there is a current flow from the anode to the cathode of this cell, which completely depends on the amount of oxygen that's in the atmosphere around it. Essentially, the metal anode dissolves around it with electrons transmitting to the cathode. Again, depending on the amount of oxygen that's there. There is a little bit, the chemistry around it is a little bit complicated, so I'm not going to talk about that today. But just be aware that this cell then will be changed out every 6 to 12 months or so. But it gives a very linear output depending on the oxygen concentration that's there. It can be ppm range or percent range. It again can be provided with a sample system. It can be used in general purpose areas or intrinsically safe requirement areas, and as a local display and a 4 to 20 milliamp output. You want to move on a little bit. Again, you can see the OxyIQ here with the corresponding cell to the right. The sample system can be very compact if required, or it can be customized as required. So if you have a requirement for a sample system with 5 transmitters in there with displays, this is not an issue. We provide all of these. Again, provide a standalone or in a standardized sample system or customized sample system. Supply is 24 volts and it's a loop powered transmitter, so it has a 4 to 20 output. The same 2 wires that power the unit also provide the signal.
Certainly. Thank you very much,
Sure.
Mark, for joining and providing that info for us. Just to touch on, we have had a couple of questions. I will encourage you, for those that have just joined in, please, you can utilize the chat window as well. We have quite a number of people that can answer the questions on here as well.
I have a question. This is Muhammad from Jordan, Total. Can I proceed?
Yes. If you want, you can submit your question on the chat, and then we can also discuss it further at the end of the session as well. Certainly. Thank you. Next, we're going to go ahead and transition over to Lachlan. Lachlan, would you like to tell us a little bit about moisture?
Sure. So, hi, everybody. We're going to discuss the aluminium oxide sensor here. So we're looking at moisture measurement. Now, when we talk about moisture measurement, we're measuring moisture in the gaseous phase. So it's water vapor, not in the liquid phase. So the aluminium oxide sensor, it's a sensor that basically acts like a capacitor. It's got 2 electrodes and with an oxide layer that is filled with air, nitrogen, and other gas. When exposed to water vapor, microcondensation occurs in the pores, and therefore the capacitance in the sensor increases. This capacitance is calibrated against dew frost point references at multiple points. So it's not a linear function. It's more an exponential. So we don't do a 0 and span calibration. We do a multi-point calibration from about 14 points of measurement. We can measure the trace moisture in many gases, but it also allows us to measure trace moisture in organic and non-miscible liquids such as hexane, toluene, various other hydrocarbon liquids as well. So the same sensor technology will measure in both different phases. So if you want to just move on, Hunter. So the sensor itself comes in two flavors, really. We've got our analog sensor there on the left and our smart sensor on the right. The sensor itself is the same on both, but it's more how the signal is processed by it. The one on the left needs to be connected to an electronic analyzer, which will do the signal processing for the signal that is generated by the sensor via that cable you can see there. Whereas the smart transmitter actually does the measurement conversion in the electronics that will be contained in that black case there under that says MIS Probe 2. Now, again, that would still be connected to a moisture analyzer, but you're able to use much longer cable runs with it. It also has the ability to store the calibration curve of the sensor directly on it, whereas the analog sensor, you must enter the calibration curve into the analyzer. Each sensor has its own unique calibration curve. So, you know, when you're using it, you got to make sure you got the correct cal curve associated with it. The one on the right, the MIS Probe 2, you can also have a temperature and pressure sensor integrated into that. So they would be contained under the sintered shield you see there. So it allows you to make a number of measurements apart from dew point. You can measure parts per million, RH, parts per million by weight or by volume, and any other derivatives of that, millions of pounds per center cubic foot, et cetera, et cetera. So they're the kind of the core sensors. So if you just move on to the next slide there. So these are the analyzers that those sensors will be connected to. In the bottom left-hand corner, or yeah, the bottom left-hand side, you can see the moisture IQ. So that's our multifunction, multi-channel analyzer. So you can connect up to 6 sensors to that at one time, from 6 different measurement points in your plant or facility, all measuring different processes. And it's got a touchscreen display, communicates over RS-45, you've Modbus, you have Ethernet functionality, you've internal data logging, and it comes, what you see there is kind of the bench mount version, but you've also got the option of having a rack or panel. And then if you're required to have the instrument installed in the field, there's a weatherproof Class 1 Div2 version and a flame-proof EXD version. So it comes in many flavors. On the right-hand side, then you start to see some of the other analyzers and transmitters that can be connected to the sensor. The dew IQ is the second one from the top right there. That's a single channel analyzer that you can connect a sensor to. The top right-hand corner then is what we call the HydroPro. So that's our transmitter. So that outputs a 4 to 20 milliamp signal. And it also has a field display there, so you can have it mount in the field and take your measurement locally, as well as having the signal transmitted back to your DCS. The HydroPro comes in both intrinsically safe and flame-proof versions. Underneath that, in the bottom right-hand corner, you've got what's called the PM880. So that's our portable moisture analyzer. So that electronics, you'd hook it up to one of the sensors that you've seen on the previous slide, and it allows you to make moisture measurements on the go. It's intrinsically safe, battery powered, 8 to 12 hour battery life, data logging, multifunction, portable, very rugged, very dependable analyzer. And then the last one, then the one you kind of see in the middle is called the MMY30. So that's, again, it's another transmitter. It has the advantage of an inbuilt flow cell, which allows you to connect it directly onto process pipes for applications like instrument air, where the pressure isn't too high, but you can make it at the process pressure. All these sensors that we saw on the previous slide, so it's the same fundamental technology on each sensor, and you just have basically different analyzers that they can be connected to here. So depending on what you need to use it for, the sensor itself will most likely be mounted in a sample system. It's not really recommended to mount it directly into your process pipe, just due to temperature and pressure considerations. So these sample systems are something we design and supply as well. So if you want to move on to the next slide, Hunter. So the other main moisture technology that we have in our portfolio is our Aurora. So this is a tunable diode laser. And the basic theory of operation is that it's the absorption of light by the molecules of a target analyte, which basically means for us, we're trying to measure moisture. So what happens is we use a laser, and it's called a tunable diode laser. So we've tuned it to a very specific frequency that when you pass it through a gas, if there's water molecules in that gas, the light will be absorbed by that. So there's basically an attenuation of the signal due to the presence of water. So it's the light passes through the measurement chamber, it hits a mirror and is reflected back through the optical window into the measurement head. So we've some photodiodes there. Initially, we measure the full intensity of the light because it's unattenuated. That's a very dry environment. There's desiccant in there, so it's less than 1 ppm in there of moisture. And then the signal photodiode measures the attenuated signal, and fundamentally we're measuring the difference between the unattenuated signal and the attenuated signal, and we're able to derive the moisture content from that signal. It's pressure and temperature compensated. So whereas the previous slide you saw the aluminium oxide sensors, they can measure at process pressures up to 340, 350 bar. We have to make a measurement at atmospheric pressure here, but we're able to do some pressure and temperature compensation on that. So that's kind of the elevator speech and how the laser works. If you move to the next slide, Hunter. So this is the analyzer itself. It's called the Aurora. The one on the left is our kind of standalone standard configuration. So it comes with a sample system. If you can see the absorption chamber there just on the right hand side of the sample system. So we've got a sample system where we're reducing the pressure, regulating the flow and keeping the temperature within the boundaries of measurements. We can design them in a custom panel based on a customer's requirements. We do have two other versions. We have a rack mount version for safe areas, and a portable version as well, which is the one you see on the right. That's called the Aurora Transport. So, like, what's the difference between laser and aluminium oxide? Really, laser is much faster. There's, one of the great challenges of moisture measurement is response time and dry down time, and it's much easier to get a faster response from a laser analyzer than it is from aluminium oxide. Now, moisture, by its nature, it's a polar molecule, so it tends to stick to surfaces. So you have to consider all your tubing, all your components. It's not just a pure sensor response time that you have to worry about. You have to take it all into account, not just the sensor, but the laser itself. It's non-contact based, whereas the aluminium oxide sensor would see the water molecule directly on its surface. So there is some additional lag time where the sensor needs to equilibrate and remove all the water molecules from it until it's reached stabilization. So, I mean, that's as quick as I've ever described our moisture measurements. I would say to get it to go through them all in 10 minutes is a record for me. Usually I'm talking for hours and hours on this topic. So, Hunter, maybe if we want to start opening up the questions now. We've got 30 minutes. Yep. That's what we're here to do, really. Let's.
Yeah, no, definitely. The best part about this is we've had several individuals already submitting questions through the chat window. So thank you all for putting in the questions that you have already. I believe that several of these have already been discussed or answered by some of our other application specialists that have been joined in on the call. We have quite a few individuals, Ken Solon as well as Nard Spargus, who are both out of our Billerica facility in the United States. So they've been offering some answers to questions, but I do want to just go ahead and work through some of these just in case you listening in weren't able to keep up with these questions as they're coming through. So one of the questions was on the XMTC, which would be the thermal conductivity meter for the hydrogen. When do you need a flowing reference versus a sealed reference? Lachlan, I know you answered this. Would you like to just get a little bit of the background on your response for that?
Yeah, sure. So for most of our applications, the two-port sealed reference is sufficient, but for certain applications where the purity of the gas to be measured is quite high, so in the 95 to 100 or the 98 to 100% range, it's preferable to use a flowing reference for that. You just you get a better signal comparison between the sample and the reference. Now, the downside of the flowing reference is that you need to have flowing. You need to be using gas while you're doing that. Now, it's a very low amount of gas, but you still need to use that or consider that. But for most of our applications, the two-port reference is with the seal reference is what we use.
Certainly. Yeah, thank you very much. We also had a few extra questions regarding the XMO2, XMTC, and their ability to be monocomposition gas chromatograph systems. I believe Nard Spargus has answered this one. More is just binary gas analyzers, whether it's for the XMO2 on oxygen, just focusing on oxygen, and the XMTC just as a binary gas analyzer. As we mentioned before, this is simply using as a background. Lachlan, is there something else you want to add on that as well?
Yeah, well, in terms of the XMO2 and XMTC, yes, they're binary gas analyzers. We need to measure, say, oxygen in a known background gas, but we do have the ability to compensate for other gases within it, and it's the same with the XMTC. We kind of call it a pseudo-binary gas because we can calculate or compensate for certain gas changes within the background. So the error might be a little bit bigger, but usually, I mean, it's still insignificant in terms of the overall measurement that's required. So
certainly, yeah.
I hope that answers the question.
Let's see. I'd seen another one that came through that was speaking to. Let's see. I'm just scrolling through right here. Just trying to see other ones that were somehow fell through the cracks on this. Settling time for the differences of the probes, the old probes versus the smart probes on ALOX, or the aluminum oxide transducers. Lachlan, to your knowledge, is there a significant settling time difference between those two aluminum oxide transducer probes?
No, there shouldn't really be, because fundamentally the technology is the same. I think what kind of we didn't mention here is that, like, over the lifetime of the aluminium oxide sensor, it will drift. So therefore, we need to the sensor needs regular recalibration. You know, probably every 12 months is a good interval. You need to do that, and what the sensor tends to do is, like, over time there's moisture that's kind of inherent in the sensor, and it gradually drifts off the sensor. So the sensor starts to read drier and drier over time. And often as customers kind of see that and go, well, excellent, well, my process is getting drier. Fantastic. But if you don't recalibrate it regularly, you end up with like kind of false sense of security. So the sensor gets sent back to us, we calibrate it, and then the customer gets it back and they start thinking, oh, hang on, there's a problem with the calibration because my reading is wetter than when I sent it in. But the reason it's reading wetter is because that's the actual moisture concentration. The sensor has been drifting drier over time. So once you recalibrate it and put it back in, it reads a little bit wetter. In terms of the stabilization time, it does depend on a number of factors. The sensors themselves should be the same, but like you have the length of tubing from your takeoff point to the sample system, how complex your sample system is. A well-designed sample system is very important here, that you don't have dead legs or other moisture traps in a system, because most of you guys are going to be measuring moisture in the very, very low levels. Like we're talking, less than 1 ppm, less than 5 ppm. So any moisture trapped in a system is going to, affect the sensor over time, because it's included in the moisture measurement.
So we have a few more discussions that have been going on as well in regards to the LDLs of Aurora and when it could be used in, let's see, it looks like LPG applications as well as moisture and liquid hydrocarbons.
So which question was that? Can Aurora be used to measure trace moisture or the LPG application? Yeah, the Aurora, like the LDL of the Aurora is 2 ppm. Okay, so we can't really measure in that very, very dry application of less than 1 ppm. In the LPGs, we have to measure in the gas phase. I'm thinking of liquids, but yeah, 2 ppm is the LDL there, so we currently can't really measure below that accurately.
And I guess a follow-up question as well to that is, what would potential other potential things be for lower than that LDL?
What would other technologies be? Or
Correct. Yeah.
or options for us? Well, aluminium oxide would be the sensor that we would use for those applications that are below 2 ppm. There are other technologies that we don't support, like quartz crystal would be another one, but that can be a lot more expensive per measurement point, and requires recalibration in the field, re-zeroing of references. So for us, we would primarily focus on the aluminium oxide sensor.
Certainly. I think this one we'll throw over towards Mark O'Brien, how the background gas curves interact with the XMO 2.
Yeah, I was just typing a response there already.
There you go.
Yeah, well, different background gases interact differently with the XMO2. We find once the XMO2 is calibrated accurately with the specific gas that it's being, put into service with, then it has minimal effect on the transmitter itself, as long as we say that the unit is suitable for that application. So once the customer checks with us and say, look, here's my gas composition, will your transmitter measure with this background gas? And once it's agreed that it will, and we do that calibration here, then there should be no issue in the field with that background gas.
Certainly. I would also like to, point out, so we have had a few additional things for issues in the field as well. If there are technical issues or logistical issues as far as being able to do the moisture exchange program for the aluminum oxide transducer. Oh, go ahead.
Yeah, I saw that comment there actually, where someone was saying that it's kind of difficult working in the Middle East with trying to calibrate probes in a timely fashion, and we have a service where we would manage that entire process for the customer using our Smart Sheet tool, which is a cloud-based application where we log or we manage the time scale of various calibrations, so that he always has freshly calibrated probes available to him, and we do this quite successfully with many customers at the moment today.
Certainly, yeah, and that's also a program that I know runs globally as well.
Yeah, that's right.
We have several locations globally from Baker Hughes, Panametrics, that we host the calibration labs on those as well.
I mean, it just means being a bit more proactive from our side, and I suppose if it is helpful if we've got someone who's again proactive at the customer side. So we agree a time scale and a series of actions that will happen, and then we set up a project based on that, and then the Smartsheet tool manages the day-to-day actions that need to happen for that project, so that the customer will always have calibrated probes available to go into his process. So you're buying confidence in your measurements. So you'll always know that the readings you're seeing, are good.
Certainly, and that's exactly it. Is each process, and I believe that this was mentioned earlier as well. Each process does have certain recalibration times just based on how wet it is. It all is about inherently how much moisture continues to remain adsorbed onto the probes as well. So they'll continue to drift and read slightly higher or slightly drier over time. So it really comes down to being able to know exactly what your process is and working with your local application teams to be able to determine what the best timing is for those programs as well.
Yeah.
Let's see, looking at a few additional things on here. Lachlan, would you like to speak a little bit on how to identify a failed ALOX probe?
Okay. There's two real failure modes that you would see on an aluminium oxide. One is open circuit and the other is short circuit. So there is a diagnostic function on each of the sensors. For the probes on the left you see on the screen, we call it MH, and for the smart probe we call FH. And if the sense, you can configure the displays of your analyzers to show this diagnostic function. And if the sensor reads 0 FH or 0 MH, then that usually indicates an open circuit. If it reads very, very high, like I would say over +20, then it's a short circuit. So something has contaminated the probe where there's a conductance across the sensor, basically a short, and they're the kind of two catastrophic failures that you would see in a sensor where you're more than likely going to have to replace it. Everything else then is much more likely to be a calibration issue, that the probe hasn't been calibrated in a while. If your reading is not getting what you expect, don't just start running at the probe and going, hey, there's something wrong with the probe. Look at your sample system, look at your process conditions, step back and look at the big picture, because the measurement is from the sample point to the sensor and possibly beyond. But yeah, in terms of kind of hard failures, open circuit and short circuit are the two main ones.
Yeah,
Okay.
we find as well that there a lot of the issues, the probe will highlight if there's an issue, but the issue mightn't necessarily be with the probe. So you could have a leak in your sample system. The customer might have a filter that's blocked upstream. These kinds of things will ultimately show up in the moisture sensor itself. It gives you a reading. So then it's how you interpret that reading. That's it's really about education sometimes.
Certainly. So if we're touching on that and we're discussing a little bit about possible ways of detecting failure, or what could generate a failure, obviously for aluminum oxide transducers, there's a few different ways of us being able to tell and identify that. Mark, would you like to speak to some of the possible failure modes or ways of identifying measurement failures for some of the gas equipment?
Well, yeah, I mean, you've got, I suppose, two classes of failures with analyzers. One is a physical issue where you have a blockage in your pipe, or your flow rate's too low or too high. And then the other side is the electrical side. So if the transmitter is either dead or it's giving an erratic reading, because again, it comes down to, a lot of it's down to training and education. So if an XMO2, for example, is calibrated for use in a certain gas composition, and then that gas composition changes. So if the customer's process changes over time, and now all of a sudden he's saying, well, the analyzer is not reading correctly, it may be that the gas composition isn't the same as the unit was calibrated for at the beginning. So that's one thing. So this is why we recommend periodic calibration on the XMO2 and the XMTC, just to make sure that your analyzer is always calibrated for the gas it's measuring in. So the electrical side of things is usually pretty obvious. So if your display is not working, you can check the display, just check the output from the transmitter. Do you still have a 4-20, and is that 4-20 being displayed on your transmitter? So again, there are troubleshooting instructions that we have in the manuals for each of the analyzers. So, and they cover 90+% of the issues that you may see or may encounter over the long lifetime that these transmitters have.
Certainly, and Mark, that certainly does bring up a great point. Much of the content that we're able to talk through today is still very high level. The user manuals definitely do have a lot of specifics for each of these applications. I believe both Lachlan and Mark had a say in some of the topics that were included on those manuals as well. So If you want to dive into parts of their brains, as well as many of the other engineers that have been supporting us through the chat windows as well, take a look at some of those manuals, and they definitely can help. In addition to, if you want to have a deeper understanding, a deeper knowledge of your specific applications, please utilize the website, the panametrics.com/training. Definitely, we can get a customized course developed to be able to have a 1 or 2 day session on site with you. We can also do remote sessions as well, as we're working through the current situations that are occurring for everybody globally right now. Another thing as well, speaking of the issues that we could see on ALOX or even the gas analyzers, Lachlan, is there anything in particular that you want to point out from the moisture measurement on the Auroras? Potential ways of identifying failures, or if there's anything else.
Yeah, well, the Aurora is a fairly intuitive analyzer in terms of if there's something wrong with it, it'll tell you. There's a large number of error messages that will scroll across the top of the screen. I suppose the most common one that we would see is a weak signal error. And what that generally relates to is something from the process may have broken through the sample system of the filter to the mirror that is located at the base there. So like under normal circumstances, that mirror should be kept very clean, highly polished, because the signal path is quite defined from the laser back to the photodiode. So the Aurora is able to handle some attenuation, of a dirty mirror, but eventually there may be, some oils or some, contaminants that have hit the mirror. So you'll get a warning up on the screen saying weak signal error, please check mirror. So it's very easy to do that. You just, you shut off your process, you make sure it's safe, that there's no gases that could be hazardous before you open up the absorption cell. And using the maintenance kit that comes with the Aurora, you can take the flange off the bottom of it, look at the mirror, you can clean it. So just using lens tissue and some acetone, and you can reinstall it, purge with nitrogen for an hour or two, and you can be back up and running in a couple of hours. So, that's the one we've seen the most, I think, generally process related. There are some other issues that we've seen where we can remotely repair it. It's very rare that there's a hardware failure on the Aurora. That means that it has to come back to the factory. There's a number of ways in the settings to kind of recapture the signal if it loses the water peak for the moisture measurement. And most of the Aurora issues that I've worked on have been resolved remotely, rather than having to send somebody to site and physically take the unit back and get it repaired. So it has that functionality.
Thank you very much. A few more comments have been made as well for being able to hold spare aluminum oxide transducers on site. Just as we've mentioned in the past as well, being able to have a spare is definitely valuable to have on site. The moisture exchange program that was mentioned before it can be customized to where you can rotate through even your spares and maintain exact quantities to whatever best suits for your applications in your facility as well. Looks like we've had most of these questions answers we're going through. We will also ensure that everybody has access in the next week or so to the full Q&A from each of these questions as well. Lachlan or Mark, is there anything else that you see that I have missed through the questions?
I see there was a mail there from, or a message from Joseph Kraus. Is it possible to remove or replace the sintered filter of the Alox Pro, some pollute or something? Yeah, the answer is yes. You should be able to order spare filters from us. You can also clean the filters if you've got. They can be cleaned in distilled water and hexane, or a non-corrosive solvent, shall we say. And then dried out and replaced. But if the fouling is too much of them, yeah, it should be. Like in a good system, the filtration will be upstream of the sensor. So that sintered filter that sits in the sensor is really, it's a secondary filter. It's 100 micron. So in a well-designed system, there'd be a primary filter before that of maybe 7 microns, or a coalescing filter to prevent any liquid droplet carryover onto the sensor. But yeah, it is possible to change those filters. There's a question from DM about a MTS6 package for ozone generators. The analog output goes for a walk. The analog output drops to half the reading. It should be.
Yeah. Narge came back on that one, I think, did he?
Okay, did he? Yeah. I mean, that could be. I would first check. You can do on these analyzers like the MTS6. You can do a test output, so you can fix the output at say 50%, and look at that and see if that's staying stable. If it's not, then there could be a problem with the device itself.
A good check, and as well they could do. He mentioned he had 2 of them. Is that swap them over? So does the problem follow the display or the analyzer, or does the problem stay where the issue is, or at the original location? In which case there might be an issue with some kind of wiring problem or something else electrical in the area. So that's a simple check they could do as well. He mentioned they had 2 and one didn't show the issue, the other did, so they could swap them out and see if the problem follows the MTS6.
Certainly.
And the other thing, Hunter, is just a general one, that just to pass on our email addresses to everyone who attended the call today. So if they have any further questions or any other issues, that just to reach out, and we'll get back to them as soon as possible.
Most definitely, yes. For those of you that have been on previous calls with us this week, we will be sending out a follow-up email directly following this. It has my contact info that'll be copied in, and we'll make sure we include in both Mr. Mark O'Brien and Lachlan McNamara as well. It looks like we have one last question on Aurora. Lachlan, would you like that?
Okay, from Joseph again. Do we need an initial calibration or fine tune for the expected gas composition? Yes, that's a very good question, and the answer to that is yes. I suppose I didn't explain it very well, but one of the fundamental differences between aluminium oxide and the Aurora is that generally the aluminium oxide is background insensitive. So you can put the aluminium oxide sensor into any application where there isn't an interference with the moisture signal, such as by a substance such as glycol or something like that. But the Aurora does need to be calibrated in its specific background gas. So for the laser, like generally what we will do is, like me as an application engineer, we will ask you, the customer, for your process composition, and we'll review it, and we can then calibrate the Aurora in the factory to your specific background gas. So that would be the initial calibration, and then after that, it shouldn't need calibration ever again. It's a one-time cal on the Aurora, whereas there's no drift. As long as the process conditions stay relatively the same, the Aurora will continue to make the same moisture measurement over many years. And I see Ahmed Masood has asked a kind of follow-up question there on, does the Aurora require periodic validation? The answer, validation is
different to calibration.
Yes, validation is usually a site requirement. So do you as the customer, do you trust the reading? So if you want to validate it yourself, you can use, you would have to have a validation technique for ensuring that the Aurora is still measuring. What I would say with that is moisture is a very difficult one to get a good validation system out of. A lot of the time, people use calibration bottles, okay, in the fields. And for most substances, that's fine. Like, if you're measuring, if you're doing an oxygen calibration, you can get 5 ppm of O2 and N2 very easily from, Praxair, Air Liquide, any of your suppliers. But when you get a moisture in a gas, it's not as straightforward as just hooking the gas up and taking a reading. Moisture is a polar molecule, like I said, so it'll tend to stick to the inside of the bottles. It's temperature dependent. So like the calibration of the bottle at the gas supplier is usually done at 20, 25 degrees or room temperature. But if you're doing it in the field at 30 or 40 degrees, due to adsorption effects, you're likely to read a higher moisture reading out of it. So it can call. We've always had, shall we say, conversations with people when they go to validate moisture readings with using calibration bottles. You really have to pay attention to the process conditions that you're doing it in. So, sorry, long story short, you can validate it with a second Aurora transport. Thank you very much, Amy. That's a very good point. But it's a validation. You don't need, you're not performing an adjustment on the signal.
Correct. Yeah, and Lachlan did mention you are able to do that at your facility if your facility or your region requires a third party. Our regional service teams are also available to be able to do the Aurora health check, similar validation procedures with an Aurora transport as well. One last question that just came in, I want to make sure is covered, is the moisture exchange program available in the Middle East? Mark and Lachlan, you can answer this, but to my knowledge, I believe that this is a global exchange program. Correct?
Yeah, well, we can run one of these projects from anywhere. So yes is the answer.
Yeah, we have a moisture calibration lab in Abu Dhabi, so it can be done locally. It can be in region.
Certainly.
So
well, with that,
if Thomas needs further information on it, just drop a line to Hunter, myself, and Mark, and we can point you in the right direction.
Certainly. With that, I would like to just thank one more time to Mark O'Brien, Lachlan McNamara, the rest of the Baker Hughes, the Panametrics engineers, and the rest of the team that have been on the call to assist as well. I would also like to thank you for joining. Thank you very much for your time. This will go ahead and conclude our discussion today on the theory and maintenance of Panametrics gas and moisture analyzers. Should you require any further questions, whether that's regarding training or products or anything else, please let us know how we may be able to reach out and help you at your facility. Please continue to stay safe, and we look forward to speaking with you again soon. Thank you.
Okay, goodbye, everybody. It was a pleasure to talk to you all, and hopefully we'll connect again soon. Stay safe.
Thanks for everyone, and thank you, Hunter.